After determining the interest rate, we are going to discuss next about comparing types of interest rates. So first, we are going to compare nominal and effective interest rates. So there are several types of interest rates which we are going to compare in this topic. So the first one is this, the nominal and effective interest rate. The formula for the two was derived by comparing amounts on simple interest formula using effective rate W compounded annually for 1 year, and compound interest formula using the nominal rate J compounded M times for 1 year. So the formulas are, for the effective interest rate, that is equal to W, or that is 1 plus I raised to the exponent of M minus 1. And take note, our I is equal to J over M. And then for the nominal interest rate, that is equal to J is equal to M times the quantity is 1 plus W raised to the exponent of 1 over M and then minus 1. So for example, find the effective rate equivalent to 14% compounded quarterly. So we have to find for the effective interest rate given the J or 0.14 and then M is equal to 4. So using the formula in finding for effective interest rate, that is 1 plus I raised to M minus 1, and then substituting for the value, since again I is equal to J over M, we have to divide 0.14 by 4, and then adding 1, and then raising the value to the exponent of 4, and then subtract 1. So 0.14 divided by 4 is equal to 0.035 plus 1, that is 1.035, and then raised to 4, that is 1.1475, minus 1, that is 0.1475, times 100 for the percentage form, that will be equal to 14.75%. This is our effective interest rate. Second example, find what rate compounded semi-annually is equivalent to 15% effective. So the given is the effective interest rate W, which is 0.15, and then our M is equal to 2. So we have to find for the nominal rate J. And then using this formula, M times the quantities of 1 plus W raised to the exponent of 1 over M minus 1. Substitute. M is 2, and then W is 0.15, and then the exponent is 1/2. So 1 plus 0.15 is 1.15, and 1/2 is of course 0.5, and then raising this one to the exponent, 1.07238 is the result, and then subtracting 1, that is 0.07238, and then multiplying 2, that is 0.1448, times 100 for the percentage form, that is 14.48%. The next comparison of types of interest rate will be about the nominal and the simple interest rate. So supposing we have to determine the simple interest rate R, which is equivalent to a given nominal rate J compounded M times 40 years. So the formula in finding for the simple interest rate R, that is equal to the quantity of 1 plus I raised to N minus 1 all over T, or the number of years. And then finding for the nominal interest rate, that is equal to M and times the quantity of 1 plus RT raised to the exponent of 1 over N minus 1. For example, what simple interest rate is equivalent to 10% compounded semi-annually for 5 years? So the given J is equal to 0.10, M is 2 because that is semi-annually, T is 5 years. And then we are going to find for the simple interest rate R. To do that, we are going to use this formula, and then we have to substitute, since I is equal to J over M, so our 0.10 will be divided by 2, and since N is equal to T times M, so that is 5 times 2, because our T is 5, our M is 2. So 0.10 divided by 2 is 0.05, and 5 times 2 is equal to 10. And then adding 1 and 0.05, that is 1.05 raised to 10, and that will result to 1.62889. subtracting 1, so that is 0.62889 divided by 5, which is equal to 0.1258 times 100 for the percentage form, that is 12.58%. That is our simple interest rate R. Next one, what nominal rate compounded semi-annually is equivalent to 8% simple interest for 3 years? So the nominal rate is the unknown, given R is equal to 0.08, M is 2, and then T is 3 years. So using the formula in finding for the nominal rate given the simple interest rate, that is equal to this formula. So substituting, so that is 2 times the quantities of 1 plus 0.08 times 3, and then to the exponent of 1 over 3 times 2, because that is T times M, minus 1. And then 0.08 times 3 is 0.24, and then 1 over 6, because 3 times 2 is 6, 1 over 6 is equal to 0.1667, and then 1 plus 0.24 is 1.24, and then raising that value to this exponent, that will be equal to 1.0365, and then subtracting 1, that will be 0.0365 times 2, that is 7.30%. So we have directly multiplied 100 to this value in order to find for the percentage form. And then the last comparison of interest rate, we are going to compare nominal rates with different frequencies of conversion. Suppose we would like to determine nominal rate J1 compounded M1 that is equivalent to another nominal rate J2 compounded M2. So the formula, so we have to just equate these two the same formula but different in values. And since I is equal to J over M, so that is equal to this formula. And for us to better understand this one, we are going to proceed with examples. So, fifth example, what rate compounded quarterly is equivalent to 8% compounded semi-annually? So, given M1 is 4 because that says quarterly, which is equivalent to 8%, that is J2 compounded semi-annually, meaning our M2 is equal to 2. And so using this formula in finding for J1, substitute for the values. Our M1 is 4, our J2 is 0.08, and our M2 is 2. And then 0.08 divided by 2 is 0.04 plus 1, that is equal to 1.04. And then squared, 1.04 squared, that is equal to 1.0816. And then we are going to transfer the exponent 4 from the side with the unknown J1. So we are going to transfer 4 from left to right side of our equation. So that will be 1.0816 raised to the exponent of 1/4. And then that results to 1.0198, and then transferring also 1 from left to right, so that is negative 1. So 1.0198 is the result of this one, 1.0816 raised to the exponent of 1/4 or 0.25. So 1.0198 minus 1 is equal to 0.0198, and then transposing 4 from left to right using the cross multiplication. So our result for this one will be multiplied by 4, so that is equal to 7.92% in percentage form. Sixth example, what rate compounded monthly is equivalent to 18% compounded quarterly? So again, J1 is unknown. Since that is compounded monthly, that is equal to 12, our M1, and our J2 is 0.18, and M2 is 4. So using the same formula, and the unknown is J1, substituting for the values, 0.18 divided by 4 is equal to 0.045 plus 1 is 1.045, and then raising this value to the power of 4, that is equal to 1.1925, and then transferring the exponent 12 from the side of the equation with the unknown. So that will be 1.1925 raised to the exponent of 1 over 12. And then the result for that one will be 1.0148. While transferring 1 from left to right, that will be negative 1. And then the result in subtracting this one is 0.0148. Cross multiplying 12, that is times 12. So the result will be 17.74% in percentage form. So your answer for this one, 12 times 0.0148, will be multiplied by 100 in order to find for the percentage form, which is 17.74%. And so that is all for the topic comparing types of interest rates. For your questions, just comment on our discussion section.